Greetings and welcome back to the channel. We're going to explore the basics of networking in this video, including how the internet effectively links billions of devices worldwide. We'll go over the definition of the internet, its architecture, and the fundamentals of information transfer between devices. By the end of this video, you'll know what occurs behind the scenes when you visit a website, send a text, or watch a video. So it's common to refer to the internet as a network of networks. This indicates that the internet is made up of millions of interconnected smaller networks rather than a single massive one. Examples of minor components that link this to a wider global web include your home Wi-Fi, your business or school network, and even your cell phone network. Your request passes via several networks each time you access a website or app, including your home router, your ISP, backbone providers, and the data center that houses your content. So why does the internet matter? More than 5 billion electronic devices are connected to the internet today, ranging from laptops and smartphones to smart TVs, watches, and even refrigerators. Unimaginable levels of communication, entertainment, business, education, and innovation are made possible by this global system. Studying computer networking, cybersecurity, or cloud computing all starts with an understanding of how this system functions. So now going into an overview of network architecture. Broadly speaking, any network consists of two primary components. One's the network edge and the network core. So computers, phones, and Internet of Things devices are all connected at the network edge. Think of this as a doorway into the internet. The fast infrastructure that carries data around the world is called the network core. I'd like to think of this as an interstate for information to move. The edge consists of hosts that includes clients and servers, as well as the access networks that link them. So as we can see in this picture here, right here would be the network core where all the information will move. You have your clients here and your servers, and these lines would be where your access networks are. So now we're going to look at the network edge a little more. So devices that request data are known as clients. These could be your tablets, phones, laptops, anything you use to connect to the internet. Devices that supply the data are called servers. Examples would include web servers that house web pages or streaming services. Additionally, we have other kinds of access networks. Wi-Fi and routers connected to an ISP are used in home networks. Workplaces with wired Ethernet and security controls use enterprise networks. Cellular towers and data plans are used by mobile networks to link your phone to any location. A smartphone, your home router, or even an Internet of Things sensor that transmits temperature data to a cloud app are all examples of edge devices. So the network core is where data actually moves between several edges at the network's core. It's made up of switches and routers, which are the pieces that transport data packets to their final location. Like I mentioned in the last slide, think of this as the internet's highway system, with routers acting as crossroads that direct traffic according to addresses. And in addition to routers, you also have switches, which function in smaller networks to swiftly route data to the appropriate device. So data moves with circuit switching or packet switching, which are the two fundamental ideas. So similar to like a phone call, circuit switching establishes a dedicated channel between the sender and the recipient. For data bursts, it's dependable, but it's inefficient. The way that the internet mostly operates today is through packet switching, which separates your data into discrete smaller units called packets that can travel via various paths to get to their destination. Modern networks require the ability to support multiple users simultaneously and make efficient use of bandwidth, which packet switching provides. So in this video, we covered what the internet is, how it's structured, and how data moves through the network. In my next networking video, we're going to look at how devices communicate, how network performance is measured, and how we keep systems secure. So look out for that video.